Hello guys, welcome back. Now let's have a look over a new temperature sensor that will be MCP9808, and it's belong to a family of MCP980X series. And let's go to the website that will be controleverything.com, and here we have to search on for this particular sensor. And regarding MCP9808, what we see, it's a maximum accuracy digital temperature sensor, plus minus 0.25 from minus 48 degrees Celsius to plus 125 degrees Celsius. And these are some more features you are able to see on my screen. And also you can purchase the sensor from this website. Also, I will be interfacing maximum accuracy digital temperature sensor MCP9808 with a BeagleBone Black, and the software platform will be C. Now to get the code, let's go to the source tab and we can have the C code sample onto our screen, and we can download the code as a zip file right from here. Also, we can have the code from github.com, and the concerned repository there will be Control Everything community. Now our next motive is to have a look upon the hardware connections we need for this video tutorial. Well, for the hardware connection setup, the first thing we require is the BeagleBone Black, which you are able to see on my screen. And this here is an I2C Shield for the BeagleBone Black. Now this is available on the website controleverything.com, and the real reason we are using this shield is to make connections easier with other I2C devices. So for that, what we require is to gently place this I2C Shield over the BeagleBone Black and make a connection just like that. For the power up setup, we require two things. The first is a mini USB cable just like this, and gently insert it over here. It is very useful to power up the BeagleBone Black. Now to power up the I2C Shield, we require a 5-volt adapter, which you are able to see on my screen, and gently insert it here. Now for an option for the internet connection, there are two mediums. The first is an Ethernet cable or a LAN cable, and the second is this, a wireless nano USB adapter. Now we have our maximum accuracy digital temperature sensor MCP9808, and this here is a connecting cable. Now make the connection among the sensor and the cable, and make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and similarly to the I2C Shield. Now as we are done with hardware connections, we need to have a look upon the C code. Now let's have a look over the interfacing part, and here we need to log into github.com, and after that we have to search on for the repository that will be Control Everything community. Now let's have a look over the code, and before that let's have a sensor that will be MCP9808, and here comes the C code. But before that, have a look over instructions part briefly, and it says that we need to set up our BeagleBone Black, and the steps are on this link, beaglebone.org. Let's open up this link so that we can have a better perspective regarding the installation process, and as you notice, we need to follow some of the instructions. Do it carefully. And after getting that, we need to download or git pull the code onto BeagleBone Black, and this command will compile and this will run the C code. Do it carefully. Now get back to the C code, and as you see, it's a .c extension file. The first thing you notice into the code that we have included some of the header files and the libraries, and in the void meet function, we are going to check whether the I2C bus is going to open or not, and then we have to check the address of the I2C device connected, that will be 0x18. Coming to the writing section part, first of all we need to select configuration register, that will be 0x01, and we are going to send a command that will be continuous conversion mode, power up default, comprises of 0x00, 0x00, and it's a 16-bit command we are going to send it, and here is the writing part, and then we are going to select resolution register having address 0x08, and the command we are going to send here is to set the resolution that will be plus 0.625 per degree Celsius, and it will be 0x03, and here is the writing command. Then we have a delay of 1 second as you notice, and next we are in the reading section part where we are going to read 2 bytes of the data from the register 0x05. Then we have the conversion of the data, which we have used some of the formulas clearly described in the data sheet for MCP9808. At the very end of our code, we need to show the output onto the screen, which you can see as temperature in both the scales, that will be Celsius and Fahrenheit. So as you know, it's a very simple and generalized code. Now our next motive is to show the working, that it's the practicality of the code and the sensor. So let's have a look over that also. Now let's have a look over the working part, and here first step is to copy the entire code as you can see on my screen. And after copying the code, we need to log in to BeagleBone Black, and we have connected it via internet, and you can see to the terminal. And as you can see, we have to create a new file with .c extension, and here we have to paste the entire code. And after pasting, the saving part is here. Now for the compilation, as you can see on my screen, it's a .c file. We are going to compile, and here are the compilation step. The code has been compiled successfully. Now to build our code, this is the command as you can notice, and when I run it, we have the temperature in Celsius and Fahrenheit scales, and when I again run it, the temperature is constant. It's almost constant because there is nothing affecting right now. But when I place my finger over the sensor and run the command, you can see there is a significant change in temperature regarding Celsius and Fahrenheit scales. When I again run it, the change is clearly visible onto the screen. So this means the sensor is working as per we desire. Now let's have a look over some of the benefits and the applications we will get from this sensor. The MCP9808 comes with user programmable registers that provide flexibility for temperature sensing applications. The registers allow user selectable settings such as shutdown or low power modes and specification of temperature alert window limits and critical output limits. This sensor has an industry standard 400 kHz 2-wire SMBus I2C compatible serial interface, allowing up to 8 or 16 sensors to be connected with a single serial bus. These features make the MCP9808 ideal for sophisticated multi-zone temperature monitoring applications like industrial applications, industrial freezers and refrigerators, food processing, personal computer and servers, PC peripherals, handheld portable devices, and a lot more. Well, you can have this sensor and you can purchase it from controleverything.com, and you can get the code from resource tab. From this site, you can download the code as a zip file. Also, you can get the code from github.com, and the repository there is Control Everything Community. In the end, I would like to make it clear that if you have any doubt regarding any part of this sensor or video, you can have your queries on controleverything.com, and you can post your comments on the community page on this website. For articles and blogs, you can have a look over on instructables.com. And to subscribe more video tutorials like this, you can have a look over our YouTube channel. In the end, I hope you enjoyed this video and had a good one yourself. Thanks a lot for watching.